ARM processor modes are nothing but the different operational states in which the ARM processor can exist, and based on which exact state it exists, its access rights to the different registers available in the system is determined. Now, the very first thing we notice here is privileged and non-privileged mode. Out of the total 7 different ARM processor mode, only one is non-privileged, all other are privileged mode. What do you mean by privileged and non-privileged mode? If we speak specifically about CPSR register, in case of non-privileged mode, it only has full read-write access to the conditional flags of CPSR, but privileged mode has full access rights to read and write any content of CPSR. That is one of the main distinction between the two. Okay, now let's come into the detail of these different modes. The very first thing that we have is user mode. If simple application is getting executed, then the processor will be in the user mode. Next, we have abort mode. If there is failed access to memory, that is, for example, if you try to access an invalid memory location or invalid address in the memory, then in that particular case, the processor jumps to abort mode. Next, we have supervisor mode. Let's assume you have just on your system or reset the system, or if OS, operating system kernel, is working, then the ARM jumps to supervisor mode. System mode is exactly same like user mode, but in system mode you do have the capacity to access, read, write or modify any content of CPSR. Next, we have undefined mode. If ARM processor is in a position where it tried to execute an undefined instruction, in that particular case, ARM processor will jump into undefined mode. So the next two, whether it is fast interrupt or interrupt request, both are different states that your ARM processor will enter when there is interrupt request arising from some hardware which requires immediate CPU attention. If the request which is made is of high priority, then ARM handles it in terms of fast interrupt request, hence it will jump to fast interrupt request mode. If it is some standard request, okay, not a very high priority one, some normal low priority request, in that particular case ARM jumps into interrupt request mode. One main thing which differentiates privileged and non-privileged mode is, in case of privileged mode, each of this mode have the right to modify the mode bits of CPSR register. By doing that, if the ARM processor lies in one of the modes, it can jump to any other mode. But that opportunity is not there for non-privileged mode like user mode. So this is the CPSR register, current program status register. This stores the status of the internal operations which happens in the system. Here, these are conditional flags. I and F, these are nothing but the different interrupt levels, that is nothing but interrupt request and fast interrupt request. Disable bits. This is T bit indicating thumb or arm state. Then here we have mode bits. These are used to determine in which exact ARM mode the processor should work. In case of privileged mode, these let's assume any one of these modes your ARM processor exists, then it can jump to other mode by editing the content or modifying the content in the mode bits. But if it belongs to non-privileged mode, it doesn't have this particular authority. But you consider the conditional flags here, even in case of non-privileged mode, these contents, that is the conditional flag contents, can be modified. Any other contents cannot be modified in this particular non-privileged mode. But that is not the case with privileged mode. Any content of the entire CPSR can be modified. This is nothing but the complete ARM register set. Totally there are 37 registers available in your ARM7. Out of this, 20 are called as banked registers. These 20 registers are shown here in the shaded region, and the remaining 17 registers are these registers shown here. So here there are total 16 registers and plus CPSR, so that is nothing but 17 registers. While user runs some simple application or code, your processor exists in this particular mode, that is user mode, when these 17 registers are available. And let's assume any fast interrupt request happens, then it jumps to this particular mode. If any such changes happen, you can see that R0 to R7 remains available even in this particular mode, but instead of R8, R9, which is shown here, these banked register comes into picture. That is R8, R9, R10 content, okay, they remain as it is, but they won't be visible in case of fast interrupt request mode. Instead, R8 underscore FIQ, which actually indicates fast interrupt request, and similarly R9, R10, R11, these are the registers which comes into picture or becomes visible. Similarly, if it's interrupt request mode, instead of R13 and R14, R13 IRQ and R14 IRQ will be visible. In supervisor mode, R13 SVC, R14 SVC will be available, and same thing you can see in each case. These registers will be available. The user and system mode, it uses same set of registers. So even if the mode changes from user to system, it's the same registers you're using, so content gets modified as required. Okay, only those registers which are not shared. For example, see here, in case of FIQ, it has separate set of registers from R8 to R14. For interrupt request, it has separate register R13, R14. So the ones which are not shared, they retain their values even after mode changing happens. But if there are shared registers, they will get modified as per requirement.